Hi there. This video is going to be about topic 2.6, linear regression models. The learning objective is to calculate predicted response value using a linear regression model. So when it comes to bivariate data, right, one of the things we want to do is to try to summarize the pattern we might see in a scatter plot that has a linear trend, right? We know that for univariate data, right, so quantitative data on one variable, we might have, like a histogram or a dot plot or something, and we can summarize the univariate data by locating the center, right, the mean. Okay. When it comes to bivariate data, we're going to see some scatter plot that shows a linear trend, and we can summarize this linear trend with a straight line. Okay, and so that's kind of the analogous thing. So this is in one dimension, we summarize with a single point, but in two dimensions, we can summarize with a line. Okay. Now, one of the main uses of a regression model is to allow us to make predictions, right? So if we have some explanatory variable here, right, we can use that value, right, plus the trend we see in the line to then predict some response variable. Right, so visually speaking, if I had a particular value for the explanatory variable, right, I can trace up to my regression model, my line, and then trace over to the vertical axis to get a predicted response. Okay. So that's kind of using the graph to make predictions. But because it's a line, right, and we've all taken algebra, right, we know that the equation of a line is a constant term plus a variable term. Okay, in algebra, we write y equals mx plus b. In statistics, we write it as y hat equals a plus bx. Okay, so y hat stands for the predicted response value. A is the constant or intercept term. B is the slope, and x is our explanatory variable. All right, so I thought that we can use this data set here and technology, right, to get the equation, right, of the linear model. Okay, so right now we'll just rely on technology to get us that model, and then I'll show you how to use that model to make a prediction. All right, so let me fire up the engine on my calculator. And to input bivariate data, you're going to click on Stat and Edit. Okay, and so normally we put the explanatory values in the first column and the response values in the second column. My interpretation is that I want to use the anxiety, a student's anxiety level, to predict their exam score. Okay, so let me clear out this old data. So by the way to clear out an old list of data is you put the cursor at the very top, okay, where not on a value, but on the name of the list, and then you're going to hit clear and then enter. All right, so let me put in the anxiety levels: 23, 14, 14, 0, 7, 20, 20, 15, 21, and there's a 4 there at the end. Okay. And then I'll shift over to the next column and type in the exam scores: 43, 59, 48, 77, 50, 52, 46, 60, 51, and 70. Okay. All right. Let's look at the graph first of all, right? We want to make sure that the pattern is actually linear, right, to begin with. Before we try to fit a linear model to it, we need to make sure that the data has a linear pattern. Okay. So I'm going to go to my stat plot menu. Okay, plot number 1, I'll turn it on. Okay, list 1, list 2 looks good. Okay, So from here, I'm going to hit zoom and then number 9. Okay, so what I'm seeing is, oops, there's a curve there. Probably have, yeah, has some random function there. So let's go back, zoom 9. All right, so what I'm seeing here is a negative, moderate to strong linear relationship between anxiety and exam scores. Okay, so notice I mentioned like what I mentioned, direction, strength, and form. Okay. Unusual features, I mean, maybe this point right here seems to stray a bit from the linear pattern, but not a whole lot. Okay. So the pattern here is that as anxiety increases, exam scores tend to decrease, right? That's the general pattern. Okay, or students with above average anxiety tend to have below average exam scores. Okay. All right, so let me show you how to get the TI-84 to produce the linear model, right? So we could kind of imagine that the linear model is going to be, I don't know, somewhere about here. Okay. All right. So this time we're going to hit Stat. We're going to go to the Calculate menu, and you're going to go down to option 8. Okay, linear regression, and the form we want is A plus BX, right? We want the constant term plus some variable term. All right, we just need to make sure that we have the correct lists referenced. So the X values are on list 1, the Y values are on list 2, and then we can just hit calculate. Okay, all right, so it'll tell you the form of the linear model. It just doesn't put the hat symbol on, but they should say Y hat equals A plus BX. Okay, so the intercept is about 71 and the slope is negative 1.14. Okay, so let me write that down. Okay, let me just write it here. Okay, so I can write Y hat equals A plus BX. That's just the general form. And then I can write Y hat equals 71.35 plus, no, minus, because the B value is negative, okay, minus 1.14 times X. Okay, so that's a bit better. So we have the generic formula, and then we have an equation, a model with the intercept and slope values inputted. But what would be even better is to replace the generic variables X and Y with the actual name of the variables, anxiety and exam score. Okay, so I can write predicted exam score. So the little hat symbol stands for predicted, equals 71.35 minus 1.14 times the anxiety level. Okay. All right. So that is our linear model, right? That is the equation of the line that best fits or best passes through our scatter plot. All right, so now I wonder if I go here, okay, no. So what we can do now is we can go to our function window, and we can type the equation of this line. Okay, so y equals 71.35 minus 1.14 x. Okay, and so now when I graph, it's going to add that line, that linear model, superimpose it onto the scatter plot, okay, which is pretty cool. Okay, all right. So now let's say that right, there's a new student, and we know the anxiety level of the student, and we would like to predict how well that student will perform on the exam. Okay, so let's say that the student's anxiety level is, let's pick a value that's not even here. So I wish there was a number line, but well, the lowest is 0 and the highest appears to be 23. So let's pick like 10, right? So there was nobody in the original data set who had an anxiety level of 10, right? So let's say that there's a new student whose anxiety level is 10, right? What exam score would we predict for that student? Well, what we're going to do is we're just going to substitute this value into our linear model and then just carry out the calculations, right? Don't forget to use order of operations, right? Multiplication comes before addition and subtraction. Right, so we can say that the predicted exam score for this student, 71.35 minus 1.14 times 10, and then we can just carry this out on the calculator. 71.35 minus 1.14 times 10. Okay, so 59.95. Okay, or in other words, right, a student whose anxiety level is at a 10, we would predict they would score around 60 points. Okay. Now, how accurate will this prediction be? We don't know. We need the student to actually take the exam and to record their actual exam score to know whether they hit this prediction, whether they overperform or underperform, right? So this is just a prediction. Now, something cool on the TI-84 is if you click on the trace button, right, it'll pull up a cursor and then you can go like point to point. But if you hit down on the keypad, it puts the cursor on the line, okay? And then you can literally type in any X value you want and then it will do the calculation. So if I put 10, right, see here it says X equals 10 and press enter, right? Now it has calculated the predicted Y value or the predicted exam score and it's placed the cursor at that particular location on the linear model. Okay, so let's say you know, a student scores has an anxiety level of 5. Okay, so I just type X equals 5, and then now we see the predicted exam score is 65.65. All right, what if a student had an anxiety level of 30? Okay. So notice we got an error, okay? Attempted to use a variable or function where it is not valid. Okay, so let's go to, okay. So apparently it doesn't like for us to use 30, okay? Now, I wonder why that is. Okay. So if we go along our linear model, right, we see that our data points, right, the last data point is about here, right? An X value of 23, okay? Beyond an anxiety of 23, there's no data, right? So there's no reason to believe that a linear model would continue after X equals 23, right? To try to predict beyond the range of our data is called extrapolation, which is something that we want to avoid, okay? The safest predictions are going to be predictions within the range where our data falls. So in this case, I can make predictions for, you know, as low as an X value of 0 and as high as an X value of 23, okay? But outside of, you know, that 0 to 23 interval, I really shouldn't be making any predictions. They're just not reliable because the data only suggests a linear trend here. It does not tell us whether the linear trend continues further to the right or whether a linear trend continues further to the left, okay? So the linear model is really only good for the domain of the X values, the explanatory variable. Okay. Right, one last thing that it's kind of obvious, I should have mentioned it at the beginning, is that when we're performing linear models and when we have bivariate data, both variables have to be quantitative, right? So our explanatory variable has to be quantitative and our response variable has to be quantitative. Okay.